In part 2 of our series, where we use Hess's law to find delta H of a reaction, we ended off with question 2, where we asked to find delta H for the reaction shown here and use the following reactions with known delta H's. The first thing that I would like to do is highlight all the like chemicals. Take, for example, NO. NO is found over here, it's found here, and that's it. Now, NO2. NO2 is found over here, and that's it. N2O is found over here, and that's the only place that it's found. Otherwise, we have these oxygen molecules and these N2 molecules that are not found in the final reaction. NO2 is found in the first reaction, but it's on the right side of the reaction. It's one of the products. We need to make it one of the reactants. So I'll flip the following. And if I flip it, the sign changes from negative to positive, giving me 2NO2 yields 2NO plus O2, and this changes from negative to positive, plus 113.1. The coefficient of NO2 is 1, but the coefficient here is 2, so I'll divide each of these by 2. If I divide this by 2, it becomes 1, 1, and half. Also, I need to divide this number by 2 as well. That takes care of NO2. Now let's worry about NO. Luckily for us, NO is in the right spot now that we've manipulated the first reaction, and there's also an instance of it in the second reaction. There are 2 here, and there is 1 here. 2 plus 1 is 3, so this one is correct. I'm not going to change that anyway. Finally, in our third reaction, we have 2 molecules of N2O, and we only have 1 over here. I'll divide this one by half. So let's go ahead and do that. If I divide this by half, I have to divide each of these by half. So half of 2 is 1. We have N2O. Half of this one is N2, and half of this is half an oxygen molecule. Our delta H will be halved. So 163.2 negative divided by 2 gives us our delta H. Now take a look. This is in the right spot, this is in the right spot, and NOs are in the right spot. I'll rewrite this one just for reference sake underneath, and I'll show you how they all cancel out. So this oxygen molecule will cancel out with this half plus this half. This molecule of N2 will cancel out with this one. 1 NO here plus 2 NOs here makes 3 NOs. 1 NO2 corresponds to 1 molecule here, and 1 N2O corresponds to this molecule. Let's go ahead and find out what delta H is. We have 113.1 divided by 2 plus negative 163.2 divided by 2. We end up with a delta H of negative 25.0. Delta H is equal to negative 25 kilojoules. Finally, in question 3, we're asked to do the same thing, but for the following reaction. I'm going to start by highlighting like chemicals. This one is alike with this. This is alike with this. That's ozone. We also have oxygens and hydrogens. Hydrogen appears to be in the right spot, but O3 is not. So I'm going to flip this first. That's our first change. And I'll also highlight this so that I keep track. We don't have O2 in our reaction, so that needs to be eliminated. Notice now that ozone in our reaction has a coefficient of 1. So I'm going to divide this by 2. That will get rid of the coefficient of 2 here, and this becomes 3 over 2. 3 over 2 is equal to 1.5. Also, I'll divide this number by 2. Ozone is now correct. Unfortunately, H2O needs to have a 3, but it's a 2. What I could do is multiply each of these chemicals by 3 over 2. If I multiply this by 3 over 2, I end up with 3H2. Here I end up with 3 over 2 oxygen, and over here I end up with 3 water molecules. I have to multiply this number by 3 over 2. So delta H of negative 483.6 needs to be multiplied by 3 over 2. And now everything will cancel out correctly. You see, this oxygen molecule will cancel out with this one, and the rest is part of our reaction. 3 molecules of hydrogen gas, 1 molecule of ozone, and 3 molecules of water. Using our calculator, we get negative 285.4 divided by 2 plus what we found here, which is negative 483.6 times 3 divided by 2. And we end up with a delta H of negative 863.1 kg. And there you have it. That is how to use Hess's law to find the change in enthalpy.